Project Binky in colour. Starring Nick Blackhurst. Also starring Richard Brunning. And Rex Hamilton as Abraham Lincoln. Tonight's episode, Gauging Interest. Coming up in episode 40, Nick finally cracks.
Bollocks!
I cover some old ground with a new toy. And we both wonder if we've actually made any progress at all.
Is it any different?
At the end of the previous episode, we'd come up with a whole new way of making printed circuit boards. We used that process to change the Mini's dashboard into something a lot more modern, using servos for some of the gauges and WS2812B LEDs for the backlighting, instead of those crappy incandescent bulbs supplied with most of our non-matching set of new Smiths gauges.
So in this episode, we'll pick up almost exactly where we left off, trying to make an interface to turn our printed circuit board into an instrument cluster. I say almost, because in the interim I've made a few small changes, a couple of which should address some of our more considered comments from the people who know a lot better than us. I've redone the terrible plug wiring job. It was only ever temporary until we knew what sort of current draw we were dealing with. And I've added a couple of extra sockets into the LED circuit because reasons.
And we swapped out the 7805 regulator for something a little more modern. These new switching voltage regulators are much more efficient than the linear version we originally found. They also create significantly less heat, which is definitely a consideration for our application. The TO220 package LM7805 voltage regulator gets carefully removed from our circuit board using a soldering iron and a pair of tweezers. They weren't precisely like-for-like replacements. Their contact legs had to be amputated, and some rails were installed on the board with little standoffs. The new voltage regulator is then simply soldered into place, and that's the revision complete.
So with the housekeeping out of the way, we can get on and build something, and that probably means that anyone involved in the plastic injection molding industry should look away now.
We're going to start with the most difficult of the three gauges, which is the one in the middle that houses the water temperature and the fuel level. It's difficult because it has multiple levels, so isn't on one flat plane, and all these have to interact correctly or it won't look like the original classic gauge. Along with this level, where you can see the needles, we've got another, only slightly higher, so we get a two-level effect with a little path ring down the middle. And on top of that, we've got the clear plastic covers, and on top of that, we've got the actual dash surround along with the chrome trim rings. Straightforward, it is not.
When faced with that complex a construction, a decent mechanical engineer would probably start with a base structure or chassis to tie everything together. So will we.
We don't have a plastic injection moulding set up here at the shed, but we do have a small worn-out CNC mill and a will to use it. So, while Nick gets on with that, I'm going to get the funk out.
That was an awful lot of machining, but sadly there wasn't quite enough funk to call this finished. It still needs some purposefully applied paint and a boatload of extra bits.
The bits include some legs or standoffs to fix the chassis height above the main board. So here they are, being whipped up on our clapped out Myford. This lathe is older than my mum, and coincidentally just as good at making apple crumble. The feet of those legs fit into some little shoes which are pressed into holes in the board, and here they are, also being made on the lathe. It's over to the 3D printer for the next additions, which are some little tubes for the idiot lights. These capture the photons and fire them up to the face without the light bleeding into the rest of the gauge. I love the 3D printer for this type of thing. We're going to need various pieces to make sure the light goes where we want it to. The multi-level centre gauge is particularly troublesome, so these bits will hopefully corral the light and point it to its required destination. Not all of the extra bits are as flat as your hat. This one, for example, requires a 90-degree bend, so the reclaimed toaster element gets deployed for some localised heat, and what was once an engineer's square, I think, is used as the jig. Nick mentioned some purposeful painting, and now it's time to deploy the satin black. We found that this colour apes the original black mini gauges the best, so the visible edges get covered up with it. And that's what the chassis looks like once the paint is dried and the masking tape is removed. That wasn't the whole extent of the supporting bits. There was quite a lot of additional work required to get everything we need to put it together. But I think we're about ready now.
This is the backing piece that completes the structure of our 2 centre gauges. It fits in our chassis, something like this. But we're not actually ready for it yet, because there's a lot going on underneath this, and I think it's going to be a lot easier to build it up on the daughter board. These little bits are a combination of locator dowel and standoff that allow everything to index to the rest of the dashboard. We've then got a reflector that also ties all of these little standoffs together, or at least it would if I put this together in the right order. Now this is a reflector that also ties all of these standoffs together. That reflector is perspex and therefore can create a lot of static, so we've got a buffer shield to stop interference on the servos. Unfortunately that creates a height indifference, so we've just got these little washers to make that all nice and even. Yeah, now we're ready for our gauge base piece, which should will like I said, it was a jig. Now you may be wondering, if this is the back of the 2 centre gauges, where is the scale? Well, it's here, because just like the original, we chose to make it separate. Fits on there like that. And then we can attach the whole thing to our chassis. Probably screw that on when we're sure it's in the right place. That is quite satisfying.
This little assembly is the crux of the whole gauge, to be honest, and even this one level has multiple levels within it, and is doing a similar job to this one in the original gauge.
While these standoffs nicely locate and set the height of this whole thing off the board, what they don't do is hold it on, and that is what these are for. And now we can finally sort out the idiot lights. You thought I'd forgotten. And then if I put these locator cups in their holes, sneak it out. We can actually put the centre gauge chassis in for good.
The assembly is held in by fasteners passed through from the back of the board.
And now it's all properly located, I can screw the scales on. Nice. And it's at this point that we have to pause the assembly because we've got to do something to address the lack of needles.
We can't use the existing needles out of the original gauges because they're very much part of the assembly. Plus, of course, they're just a bit crap. You can buy aftermarket needles from various places in myriad designs, but there's one source that beats everything else, and that's OEM. We looked at many different dashes to find the right needles and settled upon this cluster from some random PSA car, the Citroën Picasso or something, I forget exactly which one. But anyway, the whole thing came delivered for less than 15 quid, and the quality here will knock the socks off anything the aftermarket can supply. Predictably, in their current state, they're about as much use to us as a waterproof tea bag, so here's one of the needles being carefully and strategically decoupled from its centre cap. Others may call that being snapped and broken, but they'd be wrong. Nick's work is full of subtlety. Sometimes, though, he's about as subtle as a rhinoceros horn up the backside. They're not the right length either, so the end gets tickled with the grinder too. It doesn't matter what needles we started out with, modifications would have been necessary. I'm trying to think of some part of this car that we just bought and fitted without the need for some fettling, but if there is one, it escapes me. After some reprofiling, the last part of the pointer project is a little light polishing. With the needle now the right length and shiny, it's just the trivial matter of sticking it atop the servo. That didn't work. What if we ask it nicely? No. Nope. How about sneaking up on it? No. Okay, this calls for a whole new plan. Getting the needles to this point and adapting a servo horn to accept them, and having to use tweezers again, only this time a pair with an angle on them, and if you'd told me a couple of years ago that we'd be buying various different types of tweezers and getting really quite adept at using them, well, I'd have told you you had a foxtrot Oscar, was, how do they term it, non-trivial.
And with those done, we can carry on with the next step of the build-up, which is the second level. And that's where we want to keep it.
But he forgot that clear little lensy type thing with the 90-degree bend, so I had to take it all apart to fit it. Anyway, that level is reminiscent of this level in the OG gauge. But we're not finished yet, there's another one conspicuous by its absence. That's great! And now the centre gauge is essentially finished from an assembly point of view, so let's see what it looks like in the dark. Lots of you will have already worked out that our backlighting system is very different from the crappy incandescent floodlighting of the original. We've gone for a more modern look with through-lit icons and scales and lit needles. The best way to achieve this is do what the OEMs do and screen print the layers onto a robust flexible substrate. But that's prohibitively expensive for a one-off. So we just got our designs printed onto a sheet of acetate and then sprayed the back of them white where appropriate. One drawback to this process is that despite printing 100% black, the black wasn't really black enough, so we needed to double up the layers to make sure the black looked as black as Nick's heart, even with the backlighting turned right up. Lining them up so the white lines, letters and icons stay sharp is also non-trivial. We tried various adhesives but settled on this spray glue as it didn't react to either the print or the acetate and once cured made a good bond between the layers. Our MDF light box makes the critical job of lining the two sheets up perfectly just that little bit easier. The A4 sheet of overhead projector acetate sadly didn't come with any holes or cutouts where we need them, so to make a decent job of it we made a jig out of some offcuts and scrap plastic and used a sharp 2mm end mill to cut the sheet with some degree of accuracy. You'll recognise this print as the one for the middle layer, and after cutting it out on the mill, I 3D printed a thin support with the same cutouts that it was then glued to. That lot was then bonded to the bottom of the white outer ring. So that's how we made the backlit faces. On to the speedo next, and annoyingly, upon close inspection we noticed that this board is already set up for LED backlighting. Grrr. These outer gauges are a whole lot less complicated than the middle one, and consist of just a few additional parts. To get the light to the needle, we made a little circuit board with an LED on it, and 3D printed a shroud to keep the photons under control and pointed roughly in the right direction. We made a new diffuser for the face to sit on, and some accompanying legs that fit where the original ones did. After fitting the little shoes that the feet slide into, the speedo gets carefully placed onto the board. And then screwed from behind. We've made new faces for all the gauges. Obviously, and unlike others who shall remain nameless, Smiths, we've made sure that the fonts are all the same, the typefaces are all the same size, and the screws holding them down are running in the same direction. We've made a sort of matching set. Just a couple of more things to attend to before the speedo installation is complete. First, plugging the needle light LED in, and now you realise what those sockets Nick added earlier are for. And finally, it's the needle itself. The speedo needle has a 1mm to 1.4mm sleeve to account for the difference in the shaft sizes. That's a tricky little piece of turning. That's the speedo done. Now, on to the final part of the main instrument binnacle, the rev counter, which should have been much the same as the speedo. It really should. The gauges we got planned for the car are perfectly okay for day-to-day driving, but just for the running in period, we'd like to keep our eye on a few more parameters. Now we could hook the ECU up to the laptop and see the real-time information displayed there, but unfortunately the battery is FUBAR and it needs to be plugged in the whole time. Nor do we have enough space in the Mini for the desktop PC. It would be hard enough to install the Link Dash permanently, never mind temporarily, so we need to come up with something else. There is a better way to display the data we want, for example on a small handheld device, but conventional wisdom would suggest that that's not possible with this CAN data stream. Not for the first time, Nick won't accept that, and yet again, somehow it's become my problem. I was sitting in the public library in Thurman Street, flicking through the PC Link software one day when I suddenly came upon this dialog box. And I thought to myself, an OBD stream over the CAN lines might do the trick. So I curtailed my PC Link activities, sallied forth and infiltrated the shed to negotiate the addition of a pair of CAN lines.
Come again?
I want to try to hook up my Bluetooth dongle. See, it occurred to me that if it works the way I think it should, then I might be able to display the information on the app on my phone, and by Jove, it only went and worked perfectly. So it turns out I can get the information we want displayed on my phone, which does of course mean that Nick was right, and that'll make him more insufferable than usual, you'd think. Ironically, not long after I got all that to work, and about a week after we'd finalised the circuit board, Link came out with this, a 52mm CAN gauge. Never mind, we don't really have space for it in the dash anyway, but I'm sure it'll be useful for a future project, so for now, I'm going to hide it away somewhere safe. See, this is why we can't have nice stuff. Now apparently the thought process went like this. Smiths can't decide how the main gauge needles are supposed to sweep, so we're using a speedo as a rev counter so they match when you turn the ignition on. The speedo has a window for the odometer, and the odometer in the Smiths gauge is rectangular. The rectangular screen is a very similar size to the screen in the CAN gauge, so it stands to reason that we should make every effort to kill one bird with 15 stones and try to incorporate the CAN gauge into our rev counter. There's a twisted kind of logic there, I suppose, but frankly, I'm bored of this. I'm going for a Twix.
It's nice to see some familiar faces, and while they now do function perfectly as instruments, they're of no real use to us until we can get them to attach to their bezels. To that end, we've already got some strategically placed holes in the circuit board, and we've already made some attachment hardpoints on the back of the bezels that fitted the original clock housings. So all we need is a fairly simple interface to join the two together.
It's simple for him because this project ended up in my lap. I'm not complaining though, because I got to play with Fusion 360 and the 3D printer again. The complete interface was too big to go on the printer in one piece, so like the original clocks, I split it into two sections. There they are, screwed together. These little brass inserts are fantastic for creating fairly robust threaded holes, what for screwing things to, and they're a cinch to fit. A soldering iron up its chuff is just the thing to melt the plastic in a controlled manner, and the insert just sinks in. As well as the screw holes, there's location dowels to make doubly sure, and these seem to fit quite nicely, thank you. But before all that, the interface needs to get screwed to the main board. There's little room for error here, so it's a relief when all the screws go into the inserts perfectly. To go with the new housing, I've printed up some trim rings for each of the apertures, and a sponge insert will stop any chafing against the face. It only took some minor finishing of the trim rings to make them perfectly acceptable, bearing in mind that they'll be the only part of the 3D printing you'll actually be able to see. Just for the moment, we're going to fit the OEM indicator lights. The finishing touch to the new housing before the bezels go on is a trio of brand new polycarbonate glasses. That might be an oxymoron, but you know what I mean. There's something immensely satisfying about pulling off the protective film to expose the beautifully clear, unblemished plastic underneath.
Shiny.
At last, it's time to fit the bezel, and another piece of chafing mitigation is needed.
Nothing says proper job like a scabby ass bit of old foam. Nice.
Nice, it certainly is.
I can't actually screw that together properly yet because I haven't trimmed the circuit board, and I don't want to do that yet because this nearly finished binnacle is actually only about half of the dashboard.
It seems we've forgotten about the three other gauges.
I haven't. I've just been putting them off because I've got a feeling things are about to get tricky.
Let's use the voltmeter as our example here. On the big gauges we had nearly 100 mil of diameter to play with, but on these little ones we've got less than half of that. So finding a way of replacing the metal face with our more modern through-lit backlighting will be, as Nick rightly points out, tricky. These were lit by no more than a wing and a prayer, with the incandescent bulb firing its photons willy-nilly into the guts of the gauge and very much trusting that enough of them would make it to the face so that we could read it in the dark. There was only one tiny flaw in the plan. It was bollocks. The only saving grace with this gauge is the internals, which happily consist of a perfectly acceptable air core motor that we're very keen to not have to modify at all. Over the top of the motor, we need a little PCB with some LEDs on it, so that's the next job. But unlike our main board, we decided to create these out of double-sided copper-clad fiberglass, and we're engraving the dividing lines between the traces. This is more of a subtractive process, where our solder traces are much more of an additive manufacturing method. It takes a little bit of noodling to come up with the right design and then to program the G-code, but when it works, it's pretty cool. Plus, this is almost exactly the type of thing our little Teague mill was designed for. Getting this degree of accuracy is easy on a nice new machine, but on our clapped out mill it was impossible. So we spent some time converting all the axes to ball screws to replace the worn out lead screws. That was a job and a half, let me tell you. But the result is a machine that can spin a very small, very sharp knife at very high speed and engrave a tiny trench in micron thin copper with a high degree of accuracy. It's a two-sided board, so once the engraving is complete on the other side, a small end mill is deployed to cut the board out. And there you have it. Look closely, and you'll see along with the engraving, there's a number of half-mill holes in the board too, what for the connector. As I was saying, it's carefully positioned with the tweezers before being jabbed at repeatedly with an oily digit. Time now for the soldering iron to fix the connector to the board. And last but not least, the 50/50 LEDs also get soldered into place, and that's the backlighting board for the voltmeter done. For the oil pressure gauge, we went to a bit more trouble swapping out the bimetallic guts for a servo-powered pointer just like the centre gauges in the main cluster, but the backlighting is achieved in the same manner as the voltmeter. Speaking of the voltmeter, the drawn cup that it sits in, along with all the associated gumph to make it work, is just not going to cut it anymore. So we designed and printed something a lot more suitable. And instead of the old school clamp to hold it to the dashboard, I whipped up a nut to go with the threaded outer. That's a lot better. Now we can put the voltmeter together.
This little fly lead means we can cut most of these posts off and just use the nub as a locator. And then this post and this back part of the air core gauge are at the right height to allow the circuit board to sandwich the whole thing together. At least that's the theory anyway. And that was all a bit fiddly, but fairly straightforward. The hard bit is going to be getting the light from those LEDs to go where we need it.
In the original setup, the bulb goes in the back and the light has some not very reflective paint for it to bounce off. The only place it can come through the brass first level is that hole at the top, which is of course where the needle goes. Then it has to bounce off the top part of the middle bit of the gauge. Then it has a piece of glass at the top which in theory reflects some of it back into the gauge too. To get ours to work the way we want it to is going to take a large box of thinking grenades. Oh yeah, that's the stuff.
So what we come up with is this little lot. Hopefully goes together something like this.
Getting to this point, where truthfully it works better than we could have hoped for, has taken an awful lot of trial and error. Mainly error. That's quite the assembly.
Just needs a little bit of fettling to finish it.
We made the faces the same way as we made the ones on the main dash, printed onto acetate, back sprayed white, and then doubled up to reinforce the black. And now the whole thing can go together. Almost every part of it is indexed in some way to make sure that it can't go together incorrectly and to make sure that all the parts line up nicely. As per usual, there's an order of operations to follow, and the next part to go in is the needle. This is a delicate procedure, as the shaft has very little girth. The next piece is the upper face with the little battery icon. Then a brand new piece of perspex to act as the glass. That's held onto the body by the chrome bezel, along with its little foam isolator. The bezel is one of only 2 remaining original parts of the Smith's gauge. You may not think so, but there was never any intention of falling down this ridiculous rabbit hole. We bought the matching set of gauges with every intention of just fitting them and getting on with our lives, but fate intervened and demanded we develop a whole new set of skills. The skill of rolling a rubber ring down a thick shaft is one that was pre-existing, however. With the gauge installed in our little test rig, it's time to see if it works.
Of course it works.
Alright, keep your hair on. What's left of it? We took inspiration for the design mainly from how OEMs did it. When you look carefully at these old Peugeot clocks, you can see how the plastic is shaped and faceted to send the light where it's needed. It's easy enough to get the first level lit, but to get the light to the top to illuminate the icons took a lot more effort. We sectioned a cup to give you a better idea of how it works. The light goes from the LED up to this 45-degree angle. It then bounces across the perspex, somehow not escaping from the perfectly clear sides, and hits another 45-degree angle. The photons bounce off that angle and finally hit the last slant, but this time the surface is roughed up and that diffused surface becomes lit. The difference between this and the original voltmeter backlighting is remarkable. Anyway, back to our test rig, and the oil pressure gauge, built up in a very similar fashion, gets installed too. Our LED backlighting is designed to mimic that of the custom matching boost gauge we bought, so for a change, there's nothing much to do with that one. Apart from a completely different backlighting board, a new face, a new body, new needle, new glass. Gosh, I swear he told me this one would be simple.
I had to change the bezel.
That's true actually, because Smiths couldn't even get that to match the others. Anyway, those 3 gauges are now looking mighty fine. Fine enough, in fact, to get mounted into the actual dashboard for the first time. Oh, this is very exciting. The big nut method of fixing the gauges in place is far superior to the old clamp, even if I do say so myself. Come the final reckoning, the board will already be attached to the 3D printed surround, and then that whole assembly just gets screwed to the binnacle. But as the board hasn't been trimmed yet, we can't get to the screw heads on the surround, so for now, it's being assembled ass backwards. The main board goes on next, and that is screwed onto the surround. The final piece of this puzzle is the daughter board containing the Arduino, and that gets carefully pushed home. So what does the dashboard look like with all our clocks in it? It looks pretty good.
So if you've ever actually wondered why those plug-and-play digital dashboards like the Link are so expensive, well, now you know. It's because they're worth it.
It's just a shame you can't get them looking like this.
Exactly. And whilst I might have taken a few liberties along the way, like, upscaling the 80mm gauges to the OEM size, making sure all the typefaces match across all of the gauges, adding some 1990s chic idiot lights because, well, reasons, making the mechanical bits actually work.
Not to mention getting the matching set of bezels to match.
It could be argued that we've spent the best part of 2 years monkeying around with this to end up with something that, to the casual observer and in the light, looks exactly like what we started with. And that's great, because that's exactly what we wanted.
But after all that, what do they really look like in the dark? Not bad, I'd say. Not bad at all. Tune in next time for another exciting episode from the files of Project Binky.
Why didn't that work?
I don't know, hang on. Try that now. Brilliant!